Hello friends, welcome to Learner's Planet. Friends, this is our second session for algebraic and logarithmic inequalities. In the previous session, we have already discussed this wavy curve method. Using wavy curve method, how do we solve inequalities? And we did some 4, 5, 6 basic problems. In this session, we will discuss some more concepts. We will see how to solve modulus based inequalities, then how to solve the quadratic expression based inequalities. Okay, so once we are clear with all types of inequalities, then we will be taking the problems one by one. So let's begin this session, and I'm sure you are ready with your paper and pen. So do note down the things which are new for you, and let's move further. So friends, our main focus in this session on these three points: modulus based inequalities, where we will be discussing just very basic problems of modulus based inequalities. Then we will discuss how to use calculus to find out the maximum and minimum value of a quadratic expression. See, if I scan the last 3 years papers of CAT, every year at least one question has been asked on this topic, where you have to find out the maximum or minimum value of a quadratic expression. Now definitely there are multiple concepts used in a single particular question. That's why I'm just discussing all the concepts, then we will be doing the problems, because in a single problem, if we have to use more than one concept, then both the concepts should be clear, all the concepts should be clear, right? So wavy curve method we have already discussed. So next is this calculus, modulus based inequalities, and then quadratic inequalities. After that, once we finish up all these things, then we'll be taking the problems. So even if we have to use more than one concepts, you'll be able to do them very easily. Okay. So in the last session, we discussed inequalities like x is greater than a or x is less than a and all that, right? So on the number line, we can represent it like this. Okay, where this particular point itself a is not included. Okay, x is less than a, then the range will be on this side. So again, this particular point, the a itself is not at all included, right? So these things we have already discussed. Now suppose I tell you modulus of x is greater than a, or suppose simple example I take, modulus of x is greater than 2, right? So what happens actually, modulus converts each and every expression to a positive, right? So if x is maybe -1 or +1, modulus of is 1, modulus of 1 is also 1, modulus of -2 is 2, modulus of 2 is also 2. So basically modulus converts each and every expression to a positive quantity, right? So modulus of x is greater than 2. So this is number 2 and this is number -2. So if we have any number that is more than 2, there is no change, right? X is greater than 2 and modulus x is also greater than 2. So that's clear. But if we have any number that is less than -2 in this side, -3, -4, whatever the other number, what will modulus do? That modulus will once again convert that to positive, right? So what is, if we take modulus of -3, then it will be 3, right? So that is also greater than 2, isn't it? Okay, so modulus of x is greater than 2. The answer to this inequality is 2 to infinity, and here -infinity to -2. Okay, so that is the answer of modulus of x is greater than 2. So if modulus of x is greater than a, then a to infinity and -infinity to -a. Depends a is positive or negative, right? So here, this is how we solve a modulus based inequality, right? Now suppose we have modulus of x is less than 2, then this will be our answer. This is the range when modulus of x is less than 2, right? Because suppose you have -1, so modulus of -1 will be 1, right? So modulus of -1 is 1, so 1 is less than 2. Okay, so this is the answer of modulus of x less than 2, and this is the answer where modulus of x is greater than 2. Okay, so modulus of x is less than 2, that means it is minus 2 to 2. This is your answer. Okay, now once again, if you have any sign of greater than equal to, then according to that you can make the changes. If it is modulus of x is greater than equal to 2, then these brackets can be changed. The round bracket can be changed to square bracket. Similarly, if modulus of x is less than equal to 2, then change the style of the bracket. So here minus 2 and 2, both of them are included, right? Now let's take one very basic problem on the concept that we have just discussed. Just a single problem, then we'll move to the next topic. So here modulus of 2 upon x minus 4 is greater than 1, right? So you have to solve two inequalities. The first thing is 2 upon x minus 4. Suppose this is p, right? I do just that way. Suppose this is p. So if p is greater than 1, modulus of p is greater than 1, that means p has to be greater than 1, okay, and p has to be less than minus 1. So these two inequalities we have to solve, right? So 2 upon x minus 4, if it is greater than 1, that means 2 by x minus 4, it should be greater than 1, that is the first thing, and 2 upon x minus 4, that should be less than minus 1. So in both these conditions, modulus of 2 upon x minus 4 will be greater than 1, right? If you take modulus of this, that will be greater than 1. Okay, so now we have to solve these two inequalities. Okay, so once again, we should not do cross multiplication. So I just shift everything on this side. So 2 minus x plus 4 upon x minus 4 is greater than 0. So here it is 4 plus 2, 6 minus x. So if I make x minus 6 upon x minus 4, it should be less than 0. Okay, so we want it to be less than 0, so x should be between 4 to 6. Okay, the same method, Viveka method, you can use and find out x should be between 4 to 6. Now this 2 upon x minus 4 is less than minus 1. So 2 upon x minus 4 plus 1, it should be less than 0. So 2 plus x minus 4 upon x minus 4, it should be less than 0. So here it is x minus 2 upon x minus 4 should be less than 0. So x should be between 2 to 4, right? So that means x can take two values. X has two range. X can be between 2 to 4 and x can be between 4 to 6, right? Neither 4 nor 6 over here and 2 and 4 over here, none of them will be included. The values will be from 4 to 6, between 4 to 6 and 2 to 4, because we want this expression to be greater than 1. It should not be greater than equal to 1. So do not make that mistake. Okay, so the answer to the problem is x belongs to 4 to 6 union 2 to 4. So that's your answer. So the problem is just very simple. The basic method remains same as we have discussed in the last session. The only thing is you need to solve two inequalities. Okay, if you want it to be less than 1, then the similar thing, it should be less than 1 and greater than minus 1, right? So the answer, this method will remain same. So I hope this thing is clear to you. Don't worry much about it. We will be taking lots of problems. Okay. Now friends, the next thing which we are going to discuss over here is the maximum or minimum value of a quadratic expression, right? So before we learn that, before we discuss that, we should be knowing the basics of quadratic equation. I'm not going to discuss the roots and all that in detail, but yes, the brief knowledge of graphs is necessary to understand this. Okay, so ax square plus bx plus c, this is a quadratic expression. If a is greater than 1, then a is greater than 0. I'm sorry. If a is positive, then the quadratic expression will represent a graph, a parabola that is opening upwards like this, right? If a is less than 0, that means if a is negative, the parabola will be opening downwards, right? So First of all, we take the cases when A is positive. That means all the parabolas will open upwards. Now, when the parabola open upwards, still we have the three situations, three conditions or three situations, right? So, these are the three situations. Parabola in all the three cases it is opening upwards, but all the parabolas are different from each other, right? In this case, this is our axis, this is y-axis, this is x-axis. Parabola is intersecting x-axis at 2 points. Parabola is not intersecting x-axis at all, and parabola is touching x-axis at 1 point, right? So these three different graphs, they give they tell each one of them tell a different story. Okay, now what is the story? So see, ax square plus bx plus c, okay, this is the quadratic expression, and we know what is the discriminant. How do we find out the value of x? X is equal to minus b plus minus b square minus 4ac upon 2a, right? Here a is coefficient of x square, b is coefficient of x, and c is the constant term, right? So x will take two values or one value. It depends upon the discriminant, that is b square minus 4ac. So if b square minus 4ac is equal to 0, that is the case 1. That means b square is equal to 4ac. That means this is known as discriminant. If it is 0, b square minus 4ac, if it is 0, then there is no meaning of this plus and minus. In that case, both the values of x will be same. In that case, the parabola will just touch x-axis, right? So this is the case when b square minus 4ac is equal to 0. The parabola will just touch the x-axis, okay? In this case, for a quadratic expression, since it is opening upwards, okay, you just can get the minimum value of this expression. So you can find out the minimum value of ax square plus bx plus c, right, in this case. For this, again you can find out the minimum value because you can see this peak on the bottom. Over here also you can find out the minimum value, right? But in this case, since this curve is intersecting x-axis at 2 points, that means one value is obtained from plus sign and other value is obtained from this minus sign. That means b square minus 4ac is not equal to 0. That means either b square minus 4ac is greater than 0 or less than 0, right? So if b square minus 4ac is greater than 0, that means roots of this equation is real, right? The roots of this expression are real, because the term under the square root is positive, right? So in my last session, I have already told you that you have to be careful. If you are looking for the real roots, that means the expression under the square root should be positive, right? That means if b square minus 4ac is equal to 0, that means this curve will intersect x-axis at 2 points, and the intersection points, they will give the different values, two different values of x, which will satisfy this given expression, okay? Or they are nothing but the roots of this equation, okay? So this is the case when b square minus 4ac is greater than 0. Now the third case is if b square minus 4ac is less than 0, that means the expression under the square root is negative, right? That means you cannot get a real solution for this expression, real solution of this equation. Okay, if it is greater than equal to 0, suppose, you will not get the real solution of this equation because the term and the expression under the square root is negative. That means this curve will never intersect x-axis. Okay, so this is the case when b square minus 4ac is less than 0. So the main points that we have discussed is if the curve intersect x-axis at 2 points, that means b square minus 4ac is greater than 0, that means there will be two solutions. If b square minus 4ac is equal to 0, that means two solutions, but both of them are same. Okay, So the curve will touch x-axis. In this case, b square minus 4ac is less than 0. That means the curve will not intersect x-axis at all. That is means no solution. Now in all the three cases, when the coefficient of x square is positive, you will get the minimum value of this expression, but you will never get the maximum. Never get the maximum value, because these curves are never ending, right? So whatever you keep on putting the value of x, the curve will start moving upwards, right? So you cannot find out the maximum value, but yes, you can find out the minimum value, right? And how do we find the maximum and minimum value? For that, we will discuss the basic calculus method. Okay. So next, here this is a parabola when coefficient of x square is negative. Okay, in this case you can find out the maximum value, but you will not be able to find out the minimum value. Okay, because minimum value, the curve will go to infinity. So you cannot find out the minimum value, right? But maximum is this. And once again, how do we find this maximum value? That we will use calculus method. Okay, so all these things should be clear. Why I'm telling you all these things is, see, you have to find out the maximum value, you have to find out the minimum value, you have to find out the values in a certain range also. So all this knowledge is really necessary. Okay, details of or properties of roots and everything about quadratic equation, that you will learn in algebra, right? So in this particular series, whatever is necessary for maximum and minimum value, I'm just discussing that much portion only. Okay, so I hope this thing is clear. So let's move further. So now let's take the basics of calculus. See friends, students who have done their 11th and 12th with mathematics, they know calculus very well. So for them it is damn easy. But for the students who didn't have this mathematic background in their 11th and 12th, they just need to know very basic things. Okay, we will not discuss the calculus in detail, because it will further open a new world for you, right? So that I don't want. So we will just discuss the basic thing which will be helpful for you to solve the problems based on maxima and minima. That's it, right? So for that, you need to know the differentiation of certain expression. So differentiation of, this is how we represent the differentiation. So d upon dx of x raised to n, that means n is any power, it is nx n minus 1. Right? So differentiation of x square is 2x, d upon dx of x cube is 3x square, and so on. Right? If you have two terms, maybe x square plus x, if you have to differentiate them, then you need to differentiate them individually. So differentiation of x square is 2x and differentiation of x is 1. Right? Similarly, if you have more than two terms, then differentiation of x square is 2x and differentiation of x is 1 and differentiation of any constant is 0, right? So this much knowledge is just required. So because see, all the quadratic expressions, they are the power of x is square, right? And for cubic and biquadratic, at max for that much only you need to use this method, right? So for x raised to 4x cube, if you are able to differentiate, then it will be very easy to find out the maximum or minimum value, right? So once you know the differentiation, now let's discuss how to find out the maximum or minimum value of a given expression. Okay. Now suppose you have been given any expression fx is equal to, say, ax square plus bx plus c, right? So f dash x, that is known to be the first derivative. This is the expression, this is the first derivative. So what that will be? 2ax plus b plus 0, right? So first step, what you have to do is you have to equate f dash x is equal to 0. That means 2ax plus b is equal to 0. That means x is equal to minus b by 2a. So that is the first thing. Second thing is you need to find out the second derivative. So that is actually 2a, right? Now there are two cases. If the second derivative, since a is positive, that we have already discussed, we are taking ax square plus bx plus c as a parabola opening upwards. So here a is positive. So now f double dash x is 2a if it is a positive quantity or it is a negative quantity. Okay, so if it is a positive quantity, f double dash x, if it's a positive quantity, then by putting the value of x as minus b by 2a in the given expression, you will get the minimum value of this expression, right? So at x is equal to minus b by 2a, you will get minimum of ax square plus bx plus c, right? At x is equal to minus b by 2a, you will get minimum value of ax square plus bx plus c, right? If it is a negative quantity, suppose if a is negative, so if it is a negative quantity, then at x is equal to minus b by 2a, you will get maximum of this, maximum value of the given expression. Okay, so this is how this much knowledge only is required to solve the problems based on maxima and minima of a given algebraic expression, right? So this is just, I mean, very simple thing. Okay, once again, first of all, you need to find out the first derivative, ax square plus bx plus c. It is a given expression. No comments on a, because we are discussing both the cases. So ax square plus bx plus c, if we differentiate them, the first differentiation f dash x, it is known to be f dash x, it is 2ax plus b, and the differentiation of constant is 0, right? So to find out the maximum or minimum value of the given expression, you equate f dash x to 0, right? So f dash x is 0, so putting 2ax plus b as 0, you get x is equal to minus b by 2a, right? But from this value of x, whether you will get a minimum value of the given expression or maximum value of the given expression, you need to find out the next derivative. Okay, but at every stage you don't have to, I will tell you when it is not required. Okay, so but in this particular case, I'm giving you the general example, right? At this value of x, you need to find out the second derivative. If you find out the second derivative, there will be two cases. The second derivative will be a positive quantity or a negative quantity, right? If a is positive, then 2a will be a positive quantity. If a is negative, then 2a will be a negative quantity. Okay, so if it is a positive quantity, that means at this point x is equal to minus b by a, you will get the minimum value of this expression, right? And if it is negative quantity, then at x is equal to minus b by 2a, you will get maximum value of this expression. So this is a parabola like this. Opening upwards, you will just get the minimum value, and this is a parabola opening downwards. Because a is negative, that means this quantity is negative quantity, so you will get the maximum value. That's it. Okay, so I hope this thing is clear. A very simple small concept. Once this is clear, all the problems based on maxima and minima of algebraic expression are clear, right? And every year at least one question is there where you have to find out the maximum or minimum value of a given quadratic expression, or maybe some other conditions are there that all the questions we will be taking, not to worry on that front, right? But this basic thing should be clear, how to differentiate a given expression. If it is a cubic one, then also we just take one example. In the similar manner, you can differentiate a cubic expression. Suppose fx is equal to, say, x cube plus maybe 2x square plus 4x maybe plus 1, right? So f dash x will be 3x square plus 4x plus 4. Okay, after that you need to see, depends upon the question what has been asked. F double dash x will be 6x plus 4. Okay, so depends upon the question what has been asked, but this is how we can differentiate the given expression. Okay, so I hope this thing is clear to you. Whether you have the cubic expression, whether you have the quadratic, biquadratic, really doesn't matter. Once you are clear with differentiation, you can do the problems based on maximum and minimum value very easily. Okay, so we have learned to find out the maximum and how to find out the maximum and minimum value of the expression. Now how the questions are framed. Okay, we have just discussed all these three things. When b square minus 4ac is greater than 0, this type of curve, b square minus 4ac is equal to 0, then this type of curve, and b square minus 4ac is less than 0, then this type of curve, right? So we were having the quadratic expression as ax square plus bx plus c. Okay, now if ax square plus bx plus c, if it is greater than 0, that means you will get this type of curve. That means you can see this expression is greater than 0, that it doesn't intersect x-axis at all, right? So suppose I tell you maybe x plus a, x plus b is greater than 0, right? So again over here you can use a wavy curve method to solve this inequality, right? So the question may be asked in different manner. That's why both the knowledge, both the concept should be clear. This wavy curve method also should be clear, and the maximum minimum value, this calculus method should also be clear to you. In both these cases, ax square plus bx plus c is equal to 0. In this case, it is a perfect square. Ax square plus bx plus c is a perfect square because both the roots are same. Suppose x square minus 4x plus 4 is equal to 0. So that is x minus 2 whole square. So both the roots are same, right? In this case, b square minus 4ac is greater than 0. You are having two roots. So both the roots are different. Okay, so this is like x minus a, x minus b is equal to 0. This is like x minus, यहाँ पे I do pq, so no confusion between this a and this a. So x minus p, x minus q is equal to 0. This is x minus p whole square is equal to 0. Here it is ax square plus bx plus c is greater than 0. Okay, so these are the three cases. So knowledge of both the concepts, wavy curve method, and these curves, how do we get the minimum value, the maximum value, and what are the different scenarios there, we should be clear with them. Okay. Now this is a problem from CAT 2017 paper. So just for your so you get the concept clearly. The minimum possible value of sum of squares of the roots of an equation. So how do we use the maxima minima theory over here? So just for that I'm doing this question. Okay. So the minimum possible value of sum of square of the roots of this equation. So sum of the roots of the, suppose the roots are alpha beta, right? So alpha square plus beta square will be what? Alpha plus beta whole square minus 2 alpha beta. Okay, so what is alpha plus beta? That is sum of the roots in x, coefficient of x is what? Sum of the roots in negative. So here it is a plus 3, and since it is square, so the negative will be cancelled out. That means that will be converted to positive. Then minus 2, what is alpha beta? That is minus of a plus 5. So I just make it positive. So this is the value of alpha square plus beta square, right? Now we have to find out the minimum possible value of this, right? So we have to find out the minimum value of this expression. So precisely what we have to do, if I convert this a to x, make a different question, x plus 3 whole square plus 2x plus 5, this is my fx. And I have to find out the minimum value of this expression. So what I do, I'll differentiate that. So how do we do that? If you wish, you can open it. X square plus 6x plus 9 plus 2x plus 10, right? So this is what fx is. So f dash x will be what? 2x plus 6. This is 0, this is 0, so that is plus 2. So it is 2x plus 8. So if we have to find out the maximum or minimum, what we will do? 2x plus 8 should be equal to 0. That means x is equal to minus 4, right? Now we will further differentiate that. So f double dash x is equal to 2. That means it's a positive quantity. That means at x is equal to minus 4, you will get the minimum value of this expression. Minimum value of this expression. So x is equal to minus 4, you can put it over here. So minus 4 plus 3, that is minus 1. Minus 1 square, that is 1 plus 2 minus 4 plus 5, that is 1 into 2, 2. So it is 3. So the minimum value of the sum of the squares of the roots is 3. That's it. Okay, so the concept is very simple, problem is very simple. Once you are clear, you just can see the CAT 2017 question, you are able to do it very easily, right? And once you are clear, your effort will also be reduced. You don't have to write each and everything as I have written. Initially we are writing, so the concept can be cleared, but gradually you can skip some of the steps. Okay, so I hope this thing is clear to you. So this is how we find out we use the calculus method to find out the minimum or maximum value of any. Now similarly, suppose we have to find out the minimum value of this expression, that is x square minus 5x plus 41. So what you have to do? 2x minus 5, that is f dash x, this much only you have to write. So that is actually 0. So x is equal to 5 by 2. Now no need to check further f double dash x, because that will be a positive quantity. Obviously, because the constant term will be 0 while differentiating, and x will be reduced to 1. Right? So you will get 2. Right? So at x is equal to 5 by 2, you will get the minimum value of this expression. Since this is the coefficient of x square is positive, right, that we can see over here. So you can just get the minimum value of this expression. So at x is equal to 5 by 2, you will get the minimum value. So 25 by 4 minus 5 into 5 by 2, so that is 25 by 2 and plus 41. Just calculate this much and you will get the minimum value of this expression. Okay, so this was a theta problem from previous year paper. So if you are clear with this calculus, you can do this problem very easily. Alternative method are also there, but calculus is actually the general method which you can use in second degree, third degree or fourth degree, any degree equation, right? So I hope this thing is clear. Now suppose I have one question, y is equal to 3x square minus 7x plus 4, and I want y to be less than equal to 0. Right? So I have to find out the favorable values of x for which y is less than equal to 0. That means what I have to do, 3x square minus 7x plus 4, it has to be less than equal to 0. Okay, so I can just factorize this. So 3x square minus 3x minus 4x plus 4, it should be less than 0. So here 3x minus 4. Okay. So now it's 1 and it is 4 by 3. Just draw the curve. So between 1 and 4 by 3, both included. Okay, because we are looking for less than equal to 0. So at 1 and 4 by 3, y will be equal to 0, and between 1 and 4 by 3, y will be less than 0. Okay, so very simply we can solve it. I hope this thing is clear. Now I have the other question. Maybe y is equal to 3x square minus 7x plus c. So we have to find out the value of the x when 3x square minus 7x plus 6 is less than 0. Right? So this is the case where 3x square minus 6x plus 7x plus 6, we want it to be less than 0. So what we have to do, as in the previous question, we have to factorize this, factorize that. So 6 3s are 18. So 9 and 2 will be factors, but since here we have the plus sign, so 9 and 2 will not be factors. So let's check b square minus 4ac. So b square is 49 minus 4 into 3 into 6. 18 into 4, 72. So it's a negative. That means b square minus 4ac is less than 0. That means what will happen? Roots of this equation are not real. First thing. So 3x square minus 7x plus 6 for any value of x, this will be greater than 0. It will not be even equal to 0. That means this curve will not touch x-axis at all. So the three interpretation, roots are not real. That means this expression is always greater than 0. That means this expression or this curve will never touch x-axis. Okay. So all the concepts we are clubbing in a single problem. Okay. So now what if you are to find out the minimum value of this expression, that also you can do. So how would you do that? Just differentiate this. 2 3s are 6x minus 7 is equal to 0. So x is equal to 7 by 6. So if you put x is equal to 7 by 6, you will get the minimum value of y. That means you will get the coordinates of this point. X coordinate of this point is 7 by 6. And if you put x as 7 by 6 over here, you will get the y coordinate. Okay, so minimum value you will get. So this expression is always positive. This curve will never intersect x-axis. Okay, and roots of this equation are not real. Okay, so these are the takeaways of this question. Now suppose I have 3x square minus 7x minus 6. I want this to be less than 0. Let's see, does it happen? Since here the constant term is negative, definitely the roots of this equation will be real, because b square minus 4ac should be definitely greater than or equal to 0, because that will be converted to positive. Okay, so definitely we will have the real roots of this equation, and since this is parabola opening upwards, you can even get the minimum value of this expression. But since we have to find out the values of x for which this expression is less than 0, right? So what will you do? Factorize that. 3x square, 6 3s are 18, so minus 9x plus 2x minus 6, it is less than 0, so just factorize this. 3x commonly are x minus 3 plus 2x minus 3 less than 0. So 3x plus 2 and x minus 3. Okay, so here it is 3 and here it is minus 2 by 3. So you want this expression to be less than 0, so it is minus 2 by 3 to 3. So when x is between minus 2 by 3 to 3, the value of this expression will be less than 0, negative, right? So this curve is something like this. This is 0.3 and this is point minus 2 by 3, and between somewhere these 2 points you are getting a minimum value of this expression. Negative value of this expression, and minimum value will also be between them, these two only. But what exactly will be that? For that you need to differentiate this. Okay, so between minus 2 by 3 to 3, this curve, the value of this expression will be negative, right? Now the question can be framed of maybe find the set of integers for which y is less than 0, right? Find the, this is how the questions are asked. Find the set of integers for which y is less than 0. So we have calculated that the range we have calculated, that is from minus 2 by 3 to 3, but this is the range of real numbers. Now we are looking for integers. So from minus 2 by 3 to 2 by 3, how many integers are there? After minus 2 by 3, we have one integer as 0, then 1 and then 2. So we have 3 integers. Okay, so find the set of integers, or in other ways, how many integers are there for which y is less than 0. So we have 3 integers for which y is less than 0, or what are the integers? So that these are 0, 1 and 2, right? Okay, the next question based on the same problem is maybe what is the smallest positive integer for which y is greater than 0? Smallest. See, in single question we are doing all the so many problems in a single question. Smallest positive integer for which y is greater than 0. So y is greater than 0 after 3. We are talking about positive integers. Below minus 2 by 3 also it is positive, but after 3, since we are to take the positive values, so after 3 it is positive. So we are looking for the smallest integer. So smallest integer after 3 will be 4 only, right? So smallest positive integer for which y is greater than 0, suppose this is y. So y is greater than 0, the smallest positive integer will be nothing but 4. Okay? Similarly, the next question can be framed as largest negative integer for which y is greater than 0. So y is greater than 0 in this range. Okay, minus infinity to minus 2 by 3. Negative we are talking about. So in this range y is negative. This expression y is greater than 0, right? So we are looking for the largest negative integer, right? So minus 2 by 3 is not at all integer. So after minus 2 by 3, if we go to the left side of the number line, we will get minus 1. Right? So the largest negative integer for which y is greater than 0, or value of this expression 3x square minus 7x minus 6 is positive is minus 1. Right? So 3x square minus 7x minus 6 is greater than 0. The largest negative integer for which this expression is greater than 0 is minus 1. Right? So for a single question, we started with this expression, we did so many problems based on this, right? We found out in which range it is less than 0, we found in which range it is greater than 0, find the set of integers, smallest positive integers, largest negative integers, all the problems we have done on a single problem with a single expression. So I just wish to give you the idea how the questions are framed. So if you are conceptually clear, you can do all the questions very easily, right? If you know how to find out the minimum value of this expression, how to find out the maximum value of this expression, in which range this expression will be positive, in which range this expression will be negative, if you are to find out, if you can calculate this range, okay, and this range. Okay, this is the greater than equal to 0 range, greater than 0 range, the left hand side and right hand side range. This is greater than range, both, and this is less than range, right? Now out of this range, you just have to choose the number of integers or the integers only to answer the individual questions. Smallest positive integers, so from 3 onwards, this expression is positive 3 to infinity. So after 3, the smallest number, that is integer, that is 4. Okay, largest negative integer for which y is greater than 0, so that is minus 1. So this is how we can do the problems very easily. So I hope this thing is clear, and find the set of integers for which y is less than 0. So we get this range minus 2 by 3 to 3 for which y is less than 0, but this is a range of real numbers. If you are looking at integers, choose the integers from minus 2 by 3 to 3. That's it. Okay. So friends, I hope the concept that we have discussed in this session are clear to you. We will be, in the next session, we'll be taking basic, moderate and high order level problems from previous year papers and from various mock test papers. You can also send your doubts. I have already given the mail ID in the description box. Just send the doubts if you have any. Okay, and do attend the first session before you go for the second session, because every next session is dependent on the previous session. Okay, so if the previous session is not clear, then you will feel difficulty in the next session. So in the next session, the session 3, when we are going to discuss the problems from previous CAT papers and different mock test papers, you will feel them difficult if you are not clear with these 2 sessions. Okay, so do attend them. If you find any sort of difficulty, any doubts, do let me know. Okay, I'll see you in the next session once again. Bye bye.